we're going to do some Universe Sandbox experiments. Yeah, that's right. We're going to do some small experiments. We're going to try out 3 experiments, and every of them are related to this planet called Earth, where we live on. So the first experiment we're going to be doing with the Earth is what is going to happen if we collide Earth with the smallest human objects all the way to the moons. Let's see what happens. The first thing we're going to be colliding is a pigeon, because why not? So let's launch a pigeon into the Earth if it went that. Look at this. The Earth is now going to be completely covered in dust, all because of a pigeon now. And let's launch some more pigeons into the Earth and see what happens. It doesn't really affect the Earth that much since pigeons are pigeons, they're small. But they're really starting, but if they go very fast, you know they cause a lot of issues. But now let's go from pigeons. Let's see what happens if somehow the James Webb Space Telescope fails to orbit the Earth and ends up crashing into the Earth instead. Still, not much happened because James Webb Space Telescope is actually small, so it doesn't really cause impact. It does send some fragments, but Earth, and as you can see, it's covered in dust, but for Earth itself, you don't really see a change. Earth is still looking fine, and it's still business as usual. Now, let's say we collide the Great Pyramid of Giza into, let's say, Egypt. Nothing happens. So maybe we should let on with human-sized objects, and now we're going to be yeah, there's some flooding happening right now, because they're literally crashing into the Earth right now. Time to continue. Let's launch some asteroids. Let's launch this asteroid. Oh, it actually causes problems. Look at this. Still, I don't think the Earth is going to get impacted. Now we're going to be impacting Ceres, the largest asteroid, or should I say dwarf planet in the asteroid belt. 3, 2, 1, go. And Ceres gonna... Ooh, Ceres does a huge impact to the Earth. You can see a huge crater being formed and some things. Will Earth survive this? Maybe. Now, let's see. Earth actually did. Not bad, but... However, as for the continents, some of them completely flooded. You can see some floods happening right now, as some of the water is being displaced. Now it's time to crash some moons. Now it's time for the final boss. Will Earth survive collisions from our moon? From every moon in this list. Phobos, Deimos... Oh, okay. Io, Europa, Ganymede, Callisto, Mimas, and let's just wait and some more. Let's crash all these. Titan, just the largest moon. Here, the moon of the atmosphere. Titania, Triton, which is Neptune's moon, Neptune's moon. Charon, moon, Namaka, and Hyaka, Haumea moon. And finally, Eris moon is Sonia. And all of these are going to be crashing into the Earth at once. So is Earth going to survive this insane moon collision? Let's find out in 3, 2, 1. Boom. There goes all the moons. Some of them yeah. Is Earth going to survive this? We have one more moon left. Callisto is going to crash. Callisto is the last one to crash into the Earth. And Callisto crashes into the Earth. Earth is now completely burned from all of these things. Now, will Earth survive it? And the answer is, sadly, if you collide every moon in our solar system, Earth will definitely not survive this. This is what happens if somehow every single moon in the solar system happened to crash into the Earth. And now this is the first experiment with the Earth. Let's go and go back to the solar system again. The second experiment is what happens if the Earth became tidally locked. So how do you make this tidally locked? Well, you go here, you go to the motion and click on, and you have to click on tidally lock. This will completely cause Earth to be tidally locked. So Earth orbits 1 AU away, so it's not likely to be tidally locked. And in fact, none of the planets in our solar system are tidally locked. But let's say Earth became tidally locked. Let's see what happens in 3, 2, 1. As you can see, the rotational period is now 365 days, equivalent to the orbital period. And let's see what happens if Earth became tidally locked. Now let's speed up time. Things are going to start changing. For everything to be affected, you can see this temperature chart. As you can see, nothing much happening. But as time goes on, you can see the temperature is starting to get hotter in one side of the Earth, because now only one side is beginning to get sunlight. The other one's cooling down. As you can see that this is the only section where the temperature is, because it's the side that's facing the sun. The other side is just not facing the sun. And you can see the plants have died out in the sunlight area. It's completely died out, and oh no, it looks like the greenhouse effect is affecting the Earth in this area. As you can see, although you cannot see it, if you want to see it, here's the flashlight. I don't think you can see it, but apparently, if the dark side is complete, I'll show you after everything is done. I'll show you what will the effects be when Earth becomes tidally locked. Right now, it's 1 month a second. Let's go speed it up faster. And you can definitely notice the dark side's getting way too cold. It's now negative 150 degrees. The warm side's now 200 degrees Celsius, meaning it's gonna end all the life unless you're if you're in the sunset area where you will have life. But anywhere else, it's gonna be uninhabitable. And now, let's go ahead. You can see the thing is slightly changing because apparently I don't know. It is. So that means it's now so slow. Now here's the aftermath after a long time of Earth's tidally locking. As you can see, let's go here. You can see that there's a huge amount of greenhouse effect, meaning Earth is completely dead here. It's desert-like. And here is completely frigid in sub-zero temperatures. In the equatorial zone, you can see it still has some water and continents, and I think there's probably going to be life in this area. So this is what happens if somehow Earth became tidally locked. You're going to have a warm side, a cool side, a cold side, and a temperate side, which is where you will be the only area to live on. Meaning the good thing is you have eternal sunsets, which is good. The bad news is you have less surface area of the Earth to live on. So yeah, this is Earth when it's tidally locked. So now we are going to do something else. Let's say Earth wasn't orbiting the sun in the habitable zone. Let's say something else happens. What if the sun was replaced? Remember last video that we turned the sun into ETA Carinae B? You can see it over here if you like, if you didn't miss it. Now we're going to be doing this again, but we're going to do something different once we do it. So now we're going to destroy all of the planets by putting in ETA Carinae B here. As you can see, this is the second hottest star we know of. Yes, it's not the Wolf-Rayet star ETA Carinae A, it's the B. And you can see all the planets are crashing into the ETA Carinae B. Let's wait until all the planets are gone. As you can see, Neptune and Uranus. Oh, Uranus is gone. So now let's just delete Neptune entirely. Here's ETA Carinae B. So now we're going to set up the habitable zone. And instead of Earth being in central orbit, let's say Earth decided to migrate to a different section after ETA Carinae B's appearance. Let's say Earth entered in the habitable zone of this area. So now Earth comes into the habitable zone in the same area as ETA Carinae B, and seeing what happens to Earth's orbit in ETA Carinae B. So I don't think it's that much. So as you can notice, this is close to where Earth is usually at in the habitable zone in the sun. As you can see, the orbital period is over 3,000 years. Yes, 3,000 years, meaning it's unlikely you'll ever celebrate your first birthday here. Meaning if you want to be 1 year old now, you will take 3,000 normal Earth years. Second, due to ETA Carinae B's blue hue, Earth is completely just covered in blue. Meaning if you go onto the Earth, you will see that ETA Carinae B appears super small in the sky, because apparently if ETA Carinae B was the same size if it appeared from Earth, Earth would not be even here. It would be super torrid due to ETA Carinae B's hot temperature. In fact, ETA Carinae B, just like I said, 41,000 degrees Celsius or 42,000 degrees Kelvin. That is a lot. Its luminosity is 1,000,000 of the sun, so good luck surviving on the Earth. But that's it. But if Earth was here, here's a breakdown of what will happen if the Earth was somewhere here. So the first thing is that Earth will have a longer orbital period, and second, Earth is probably gonna have the blue hue, and let's see. Here's the Earth right now. So yeah, although Earth is going to have support life, ETA Carinae B has a lot of solar is extremely solar radioactive. So I don't think there's a chance, even a slight chance, that Earth in reality is going to have life. So anyways, this is 3 experiments that's coming with Earth. the next video of Universe Sandbox will be talking about some more experiments with using our entire solar system. So thank you for watching, everyone. Tune in for the next Universe Sandbox video, which will be coming soon after this. Make sure to subscribe, and I'll see you guys later. Adios, everyone.